so much for Mas Vincent, my brother. I canceled my travel because of this event. So every time my friend Venza called me, I'll be here. So I was there since the first SETI. I was here as a Star Trek fans, and then I was here again as an entrepreneur. I was here again. I have multi-personalities. So thanks for Mas Vinza and the committees. It's happy to be here again. So my name is Erianto Rachman. I'm a writer. I have a published book called Finding God. So one of my presentation today is coming from that book. I'm not a scientist, luckily, so I can talk anything. And if the science is flawed, it's not my fault. Okay? All right, so we'll be talking about space, but let me ask you this question. So, what is the creature on this planet that is last to know about water? What creature last to know about water? Sorry?
Fish.
Correct. Why? Because it's fish. It's been in the water since forever. Right? And what about space? What is the creature? What creature is the last to know about space? The answer is us. We don't know about space. But one of the advances in physics, they talk about space and try to... One of the interesting part is space as our universe, our space is actually a holographic projection. And this is not mystical talk, this is science, right? Okay, so this is the book, this is my book. All right, so I want to start with black hole. Right, so I have 15 minutes, so let's jump into black hole. What is black hole? Black hole is a star that depleted its energy, a collapsed star. How the star is collapsed? So I take hydrogen atom is the lightest atom and abundance, right? It has, why it's light? Because it has at least three actually. There's a neutron there, but I did not put it there. So I want to focus on two, which is electron and proton, right? So electron is circling the proton, right? The nucleus, right? And the distance between electron and proton is 5.291 times 10 minus 11, just like that. So it's very tiny, right? But put into perspective, if I change the proton into the baseball, right? So electron will be 3.2 kilometers away, right? So there is an internal structure in the atom that is very vast, right? Very vast. So this is the smallest atom, and within it, there is a distance between proton and electrons very far, right? So then, electron needs energy to move. One day, the energy is depleting, right? And then it collapses into when it's out of energy, it collapses into its core, right? And between electron and proton is empty space. So when it collapses, the space in the atom becomes outside of the atom, right? So every atom in a star, this happens, right? So again, put into a different perspective, if National Monument in Jakarta, very big tall building, right? What happens if every of the atom that is, builds it, collapse? Then the monument is actually the half of the grain of rice. The actual matter is very tiny. The rest of it is empty space, right? So that's put into perspective. So black hole is like that. It's sun that collapses, and every single particle is collapsed into its core and become very small, right? Very small, but the gravity is very high, right? So this is a black hole, and this is event horizon. Event horizon where when there's a distance, there's a boundary in the black hole where it's the diameter of the black hole, right? So if there's a photon come near to black hole, what happens? Three scenarios. First, they're passing by. It passes by, but the direction will be like bent, right? Second scenario, it falls into black hole. It cannot resist the gravitational force. Second is, the photon is light, right? The particle of light. The photon will be, it's still quite strong, right? To not be sucked into the black hole, but not strong enough to escape the black hole. So there will be strands in the boundary of the black hole. So if you search for a black hole, search for a black area, but surrounded by light. That probably is a black hole, right? So that's what happened. All right. Now, in the advances of physics, we have reached like from Newton up to string theories, M theories, and things like that. M theory opens up lots of opportunity for scientists to put their imagination into mathematical equations, right? So I summarize it into like this. So event horizon is actually the boundaries between macro world, all the applicable applied physics apply into it, and micro world, where quantum physics happens. Right? So this is the boundary between macro physics into quantum physics, general relativity into quantum mechanics, right? So imagine Mas Venza going to black hole. What happened? You die, right? Sorry about that. Anyone want to volunteer? Okay, but quantum physics says no. That's not the entire story. Quantum physics dictates that it has something happen with what they call is superposition. You must die because you're a macro being, and you also live inside the black hole. So it's like Schrodinger's cat, right? It's die and live, right? If you learn about Schrodinger's cat, right? So you are not copied. This is not copied. This black hole is not a giant copy machine, no. You are the same being. You die and you live. So now, what is actually happening here is so your macro body is destroyed, and tiny bits of your information, the very tiny bit of your information, is spread around in the surface of the black hole. The other one, your other self, went into the black hole and lived in it. Right? So your information, every bit of your information is spread around the surface of the black hole and then projected in the black hole as you yourself. That's the start of the holographic concept in physics, right? So it projected using quantum entanglement. So from two-dimensional information projected into three-dimensional information. Now, I want to pause a bit. Okay, I have 5 minutes, okay. Okay, my idol, Brian Greene, he wrote something like this. If you want to, density and the black hole, so we have a lot of kind of black holes determined by its densities. So the density of a black hole, if you want to make a grade to a black hole, you have to squeeze the grade from 2 centimeters diameter into 10 minus 25, right? If you get what I mean. If you want to make planet Earth to become a black hole, you have to squeeze the Earth until the diameter is only 2 centimeters as a size of the grade, and Earth become a black hole, right? How about the Sun? Squeeze the Sun into 6 kilometers, then it becomes a black hole. So it's the So the bigger the size of the black hole, the lesser the density, right? So I'm gonna ask something else, different question, but same meaning. If you want to create a black hole the size of 4 million times of our sun, we need to concentrate on and compress matter to the density of lead. Right? Then it becomes a black hole the size of 4 million times of our sun. If you want to make a black hole the size of 100 millions of our sun, we need to concentrate and compress matter to the density of water. Pull the water into the size of now 100 million times our sun, that is a black hole actually. So what if we want to make a black hole 4 billion times of our sun? We need to compress matter to the density of air. What? What does it mean? This is now one of the physicists, I forget the name. He said, then our universe is actually a giant black hole. It means that the mechanism that we are talking about, that copy from 2D to 3D in the projection, happens right now, right? So this is a 2D, right? It's a height and length. The smallest part, it we call bit, pixel, if you want to use the pixel terminologies. And this is 3D. It has length, height, and depth. And the smallest portion of information, we call it voxel or qubit. Pixel is in 2D, voxel is in 3D. Bits in 2D, qubit is in 3D. Right? So it's actually like this. Bits, our information in the surface of the black hole being projected into qubit inside the black hole as a 3D. So using the entanglement. All right? Again, this is a WMAP probe. The satellite, it probes the density of temperature and density of our universe. So our universe actually looking like this. This is the space. This is the shape of our space actually. Yeah. So we have three options. Usually, in the old days, we thought our space is flat, right? Minkowski space. It cannot be like this. Now we know that our space is shaped like this, like a horse saddle, right? We call it anti-de Sitter space. Now, and let me skip this. I have like 1 minute. Okay. Physicists has a problem when they count about infinity. The equation collapses. You cannot deal with infinity. So our universe is infinite. So physicists needs to make a boundary of that infinity. They use it the conformal. So this is the tessellation they use. This is a graphical formation. So it's actually infinite, but it has boundaries, so it can be calculated. Yeah, they call it conformal boundary or infinite boundary. You see, it's quite strange, right? Infinite boundary. It's infinite, but it's bound. So ini akal-akalannya fisika ya. This is the space, anti-de Sitter space, and they measure it, the infinite with the conformal boundary, right? So this is our space. So again, right? This is the conformal boundary, and the internal is the anti-de Sitter space. The theory to measure the surface of our universe, they call it conformal field theory. And the theory to measure, to calculate, and to investigate space, they use quantum field theory. So in that sense, see, ADS, anti-de Sitter space correspondent with conformal boundary is actually the holographic projection. Right? So it's like this. So every being in our universe is actually projected by information in the surface of our reality. This is not me saying, this is physicists saying. Right? Every being in the universe is actually a projection from 2D information as a 3D being. Which one is the correct one? Both are correct. It's a single being. It's not like a copy, no. Will exist here and there. Alright? So this, our universe, time's up, okay? Our universe is actually a giant holographic universe projected from information written in the service of our reality. Right? So I hope I convey the message clearly enough, because I have only 15 minutes. So in the first session you talk about Akashic record, you talk about things like that. What is Akashic? What is written in the final question? Sorry, I have one more minute. What is written? What is the information written on the surface of the reality? The answer is every possible scenario, every possible history and future of our reality written in the 2D surface of the reality and projected into this. So that's conclude my presentation. Thank you.